Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 4 video from the chapter of energy, where I will solve 5 multiple choice questions based on the gravitational potential energy, kinetic energy and the transformation of energy from these two forms. This is this the solving these questions is based on the concept of gravitational potential energy, kinetic energy that I have discussed in part 3 video. So this video is part of the playlist ICSE Physics for class 8, where I primarily discuss key concepts and formula for numerical problem solving. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 4 video, where I will solve 5 MCQs on the gravitational potential energy and kinetic energy and their transformation. Okay, so the first problem says that a car is moving with a speed of x kilometer per hour and another identical car is moving with a speed of 2x kilometer per hour. If kinetic energy of second car is y times that of kinetic energy of first car, find y. Okay, so a car is moving with a speed of x kilometer per hour. Okay, so let's consider the speed of the first car be v1. So we have v1 is equal to given x kilometer. I have to increase the pen width. Okay, so let's say the speed of the first car be v1, which is given to be x kilometer per hour. Okay, now usually with the speed the unit we use is meter per second or even centimeter per second. In this problem, the unit is given as kilometer per hour. Please, it is not, for this problem it is not necessary to convert this unit to any other unit. Let it be like this. So v1 is x kilometer per hour. So what will be its kinetic energy? So if let's say kinetic energy is usually denoted with symbolically it is Ke is used, but K is also used. So let's say K1 is the kinetic energy of the first car. It will be half m v1 square. Now we do not know the mass of the car, it is not given in the problem, but it is given that both the car are identical, which means that both the car, since they are identical, they must have they must be having the same mass. So K1 is half m v1 square. On the other hand, let's say the v2 be the velocity of the second car, which is given as 2x kilometer per hour. 2x kilometer per hour. So kinetic energy of the second car, let that be 2. Let's denote the kinetic energy of the second car by K2. It will be half. By the way, so the kinetic K1 will be half m. V1 is x, so x square. This much joule. No, will it be joule? No, it will not be joule, because the velocity is kilometer per hour. Velocity is kilometer per hour. It will not be joule, but whatever it will be, it will not matter in solving the problem. So let's say I'm not using any unit, because since both the velocity are given as kilometer per hour, it will not matter much. So the kinetic energy of the first card is half m, this is m x square by 2, and the kinetic energy of the second card is half m v2 square, this is half m 2x square, which after simplification will be 2m x square. Okay, now it is also given that if kinetic energy of second card is y times that of kinetic energy of first card, so it is given that k2 is equal to y times k1. So this implies y, we have to find the value of y, so y is k2 by k1, which is equal to m x square by 2, this divided by 2 m x square. Mx square will cancel out and it will be 1 by 4. So y is 1 by 4. So the correct choice is D. D is the correct choice. Let's see the next problem. Okay. So a ball of mass small m kilogram is dropped from a point A, which is small h meter above the point B on the ground, and passing through the point C between A and B as shown in the figure. So point B is on the ground and point A is at a height of small h meter above the ground, and point C is somewhere in between A and B. Let UA, UB and UC be the potential energy of the ball at positions A, B, C respectively, and KEA, KEB and KEC with the kinetic energies of the ball at these positions respectively. Then which of the following choices is correct? Okay. So definitely we know that UA, the potential energy at the point A of the ball, the gravitational potential energy of the ball at the point A will be mgh or mhg. So mhg, this much joule, since the mass is given in kilogram and also the height is in meter. Okay, fine. Now now the problem has not asked to find the values of UA or UB or UC or even the kinetic energy. The potential energy or the kinetic energy of the ball at any of these positions, it is not asked. It is just asked whether okay, so let's see, instead of finding the okay, let's do it. So mhg, joule, is the gravitational potential energy of the ball at the position A. What will be the kinetic energy of the ball at position A? It will be 0, since the velocity of the ball, it is at rest. The velocity of the ball is the ball was at rest at the point A. So half m 0 square, a body having 0 speed is do not have any kinetic energy. So this is 0. Okay. Now at the point B, it will be the gravitational potential energy B UB will be mass. The height is 0, G J, which is 0 joule. And what will be the kinetic energy? Kinetic energy at the point B will be equal to the gravitational potential energy of the ball at the point A, because the whole gravitational potential energy of the ball when it was at position A has been transformed into kinetic energy when the ball has reached the ground. So this will be basically equal to UA, which is mhg, this much joule. Okay, so this is the basic results that we have. Now at the point C, at the point C, the ball will have both the gravitational potential energy as well as kinetic energy, but definitely we will have the gravitational potential energy of the ball at the point C will be less than the gravitational potential energy of the ball at the point A, because the position C is at a lower height from the ground. So definitely UC will be less than UA. Now also UC will be greater than UB, because it is at the point B is at the ground level. At the point B the potential energy is 0, but point C is at a certain height from the ground level. So we will have UB less than UC less than UA, UB less than UC less than UA. So I can see in choice, remember that the question has asked then which of the following choices is correct. So more than one choices can be correct. So I can see in choice B I am having the solution which is correct, that UB less than UC less than UA. Now let me see if this is correct or not. UB is 0, UB equals to 0 is correct, and kinetic energy at the B is equals to UA, so this is also correct. So definitely choice B is correct statement, so I have to select this. Now choice A is incorrect because this is incorrect, this solution is incorrect. Okay, so this is a wrong statement. Let's see choice C. UB, it is given that UB is less than UA. UB is less than of course UA, because UB is 0, but UB is not greater than 0. Choice C is saying that UB is greater than 0 but less than UA. This is false, because UB is 0. The potential energy at the point B is 0. So choice C is also incorrect, because this is wrong. 0 less than UB less than UA, this is wrong, because we know that UB is equal to 0. Okay, let's see choice D. It is saying UC is 0. No, potential energy at the point C is not 0. It will have some potential energy, and which will be less than of course the potential energy at the point A, and so definitely choice D is also incorrect. So only choice B is correct. So now what will be, so we will have at the point C the ball has lost some gravitational potential energy, and that loss of gravitational potential energy will be converted to kinetic energy. So it will have some velocity at the point C. Now that velocity will always be less than the velocity at the point B, because the total gravitational potential energy which the ball was having initially at the point A, that will be converted to kinetic energy at the point B. So velocity, we will always have velocity B will be greater than velocity C, and velocity C will obviously be greater than 0, and velocity A is 0. I hope I was able to properly explain the problem and solve it. Let's see the next problem. Okay, a body weighing W kgf kilogram force is dropped from a point P and reaches the ground point R through the point Q in between P and R. So it is given that the height, the distance between point P and Q is x meter, and the distance between the point Q and R is 2x meter. If the velocity of the body at point R is v meter per second, then the value of x and the velocity at point QR, it has asked we have to take the value of g as 10 meter per second square. Okay, so we have to find x and the velocity of the body at the position Q. Initially the body was at the point P, it was dropped from the point P. So if the velocity, and also it is given that at the point r, that is when the body has reached the ground, its velocity is v meter per second square. Now clearly I know that the potential energy at the position P will be equal to the kinetic energy at the position R, because at the point R is on the ground. So when the ball will reach the ground, it will lose all its gravitational potential energy, and that gravitational potential energy has been transformed into kinetic energy. Okay, so what is gravitational potential energy at the point P? The height m, mass is, since it is given the body is weighing w kgf, which means that it has a mass of w kilogram. So w, the height of the point P is x plus 2x, this much meter, and we have a g, this is this much joule, is the gravitational potential energy of the body at point P, which is equal to 3wx. This g is the gravitational, is acceleration due to gravity near the earth's surface, which is given to be which has been given to be 10 meter per second square. So this much joule, if you so this is if you put the value of 10 meter per second square as g, it will be 30 wx joule. 30 wx joule is the potential energy, gravitational potential energy of the body at the point P. Okay, now what is kr? What is kr? That is the kinetic energy of the body when it reaches the point R on the ground. It will be half w, its velocity is given to be v meter per second square. So half w v square, this much joule. So we can now equate up from this fact that up is equal to kr. We will have 30 wx is equal to w v square by 2. W will cancel from both the sides, and we will have x is equal to v square by 60. So the value of x is v square by 60. V square by 60, and we can see in the given choices only choice B has v square by 60. So obviously at this stage only we can say the correct choice will be B. Now let's see what will be the velocity of the body at the point Q. Now the velocity, the kinetic energy of the body at the point Q will be equal to the loss in gravitational potential energy when the body was due to falling from the point P to the point Q. So what is the loss in gravitational potential energy when the body dropped from point P to Q? It will be W, the distance between P and Q, which is x, Wx g h. This is Wxg joule, where g is the acceleration due to gravity. Joule is the loss in gravitational potential energy when the body when the body reaches the point Q. And this loss in gravitational potential energy will get transformed into its kinetic energy. So if I consider the velocity at the point Q to be Vq, this should be equal to half W Vq square. Okay. Now okay. So I can so we have now this will be this much joule. So I have Wxg is equal to W Vq square. Vq is the velocity of the body at the point Q divided by 2. So W gets cancels out from both the sides. Also I know that x is v square by 60. So I have v square by 60 multiplied by g is equal to vq square by 2. Okay, so this implies that now okay, v is g is the value of g is 10. So this implies v square by 60 multiplied by 10 is equal to vq square divided by 2. This implies, after simplification, 10 cancels 60 with 6 and 2 cancels and 2 cancels 6 with 3. So I am having v square by 3 is equal to vq square. So this implies vq should be equal to square root of v square by 3, which is 1 by square root of 3 into v. But in the choice B, it is given square root of 2 by 3 v. Let me see if I have done any calculation mistake or not. At the point Q, what will be the kinetic energy of the body? So if the velocity of the body at the point Q is Vq, its kinetic energy will be half mv square, where m is w kilogram. Now this gain in kinetic energy at the point Q should be equal to the loss in gravitational potential energy, which must be w mh, the distance between P and Q, which is x meter. So wxg. Okay, so wxg joule should be equal to half w vq square joule. From here we get wxg is equal to w vq square by 2. The w gets cancels out, so we get xg is equal to vq square by 2. Now g is 10, we know g is 10. Now what is x? X we know is v square by 60. X is v square by 60. So we have v square by 60 multiplied by g is equal to vq square by 2. If I put the value of g as 10, then we get v square multiplied by 10 divided by 60 is equal to vq square by 2, 3. So definitely we are getting v square by 3 is equal to vq square. From here we get vq is equal to 1 by square root of 3 v. I don't know, I might have done calculated, I might have done when I was solving the problem, by mistake I might have calculated the value of vq as square root of 2 by 3 v. But I can see now I am solving the value of v. The value of vq is 1 by square root of 3 v. So vq is v by square root of 3 and x is v square by 60. I hope you are getting the concept that I am applying to solve the problem. But I am really sorry that in many of the problems I give wrong choices. That is, the choices are not given correctly. But if you think that I am doing any calculation mistake and my choices are correct, but I am doing any calculation mistake or silly mistake or applying the concept incorrectly, then please feel free to let me know in the comment section. I will highly appreciate that. Let's see the next problem. Question number 4. An aeroplane of mass m kilogram flying at a constant height of x meter from the ground with a speed of y meter per second. Then the energy possessed by the aeroplane is. So the aeroplane is at a height of is at a constant height of x meter. So definitely it will have some gravitational potential energy. So we know that when a body is, usually the mechanical energy, total mechanical energy is equal to the gravitational potential energy plus the kinetic energy. In this problem, the aeroplane is flying is at a constant height of x meter from the ground. So the gravitational potential energy will be mgh, that is its mass, which is given to be m kilogram, m, and the height, which is x, mx, g, this much joule. G is the acceleration due to gravity near the surface of earth, which has been given to be 10 Newton per kilogram. Now remember, 10 Newton per kilogram is basically equal to meter per second square. Okay. Now what is the kinetic? What will be the kinetic energy of the airplane? It is given that the plane is also flying at a constant speed of y meter per second square. So its kinetic energy will be half mass and its speed y square, this much joule. Okay, so this is equal to, now I will put the value of g as 10. So mxg becomes 10 mx plus m y square by 2, this much joule. If I take m by 2, if I factor out m by 2, I will have this to be equal to m by 2 this will be 20x plus y square, this much joule. So this is the total energy possessed by the aeroplane, which is its the sum of its gravitational potential energy and its kinetic energy. So the correct choice is D. D is the correct choice. Let's see the next problem. Question number 5, the last problem. A rice bag weighing x kilogram force is lifted up to a height of y meter from the ground by 10 workers. The energy spent by each worker is. Now when 10 workers has lifted a rice bag weighing x kilogram force to a height of y meter from the ground. So the total work done by all the let's say the total work done by all the 10 workers, I am denoting it with W10. This will be equal to the gain in the gravitational potential energy of the rice bag. So which will be the mass of the rice bag, which is x kilogram, x multiplied by the height to which the rice bag was lifted, which is y meter, and g, that is the acceleration due to gravity, which in the problem has been asked to we have to take the value of g as 10 Newton per kilogram. So this will be this much joule. So if we put the value of g as 10, this becomes 10 xy joule. This is the work done by 10 workers in lifting the rice bag of x kilogram weighing the rice bag of mass x kilogram to a height of y meter. Now this work done is also equal to total energy spent by 10 workers. The gain in the gravitational potential energy of the rice bag when it was lifted to a height of y meter from the ground, that energy came from the energy spent by the 10 workers, and that energy spent by the 10 workers is basically also the work done by the 10 workers to lift the rice bag, which is equal to 10 xy joule. So energy spent, and since all the workers are having equal energy, so energy, the problem has asked energy spent by each worker. So energy spent by each worker will be obviously 10xy, this much joule divided by 10, because 10xy joule was the total energy spent by all the 10 workers in lifting the rice bag. So this is nothing but xy joule. So xy joule is the energy spent by each worker when 10 of them, where it is given that 10 workers lifted the rice bag of x kilogram force, a rice bag of mass x kilogram to a height of y meter. So the correct choice is B. So the important concept to understand is that when the 10 workers, so the work done, the total work done by all the 10 workers in lifting the rice bag of mass x kilogram to a height of y meter is equal to the gravitational potential energy gained by the rice bag, or possessed by the rice bag when it was lifted to a height of y meter. So the gravitational potential energy we know is mgh, that is the mass of the rice bag, and multiplied by the height from the ground, which is y meter, and g, the acceleration due to gravity. So the total work done is 10xy joule, and hence you can say that work done by individual workers will be 10xy joule divided by 10, that is xy joule is the work done by each worker, which is also equal to the energy spent by each worker. So I hope solving this problem will give you some idea of how to apply the concept of gravitational potential energy, kinetic energy, and how they are transformed from one form to the other in solving these problems. So if you find this problem beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I don't know whether I will come up with more problems. If I can, I will try. Otherwise I will start the next topic, which is power. So please stay tuned for these videos to come soon. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.